Hi everyone! The scanning electron microscope that I use for my research is located at the California Academy of Sciences, which is in San Francisco, California. The Academy is a science museum that's open to the public, and you should come visit if you're ever in the San Francisco Bay Area. Most of the people, though, who visit never get to see the research part of the Academy, which is what you're seeing now. This is the entomology department, and we're heading into the SEM room. And of course, that's me. Before using the SEM, we first have to sputter coat the specimens we want to image. Sputter coating just means that we have to coat the specimens in a thin layer of metal, which makes the specimens electrically conductive. This is what they look like before sputter coating. There are two dead insects on the small piece of metal, which is called a stub. This is the actual sputter coating machine. It is hooked up to a gas cylinder which holds argon gas, which I'll explain later. The chamber at the top is where the specimens will go. So I open the chamber and carefully place my specimen stub inside. In a moment I'll be creating a vacuum in this chamber, so I'm careful not to touch anything so as not to contaminate the chamber. Then I carefully close the lid, and now we're ready to start sputter coating. The first thing I have to do is turn on the machine. The chamber at the top needs to create a vacuum, and a vacuum doesn't have any particles of air, so the pressure in a vacuum is much lower. This gauge on the machine tells me the pressure within the chamber. I need the pressure to be about 100 millitorrs, which will create an effective vacuum. Now all I have to do is press the start button to start the sputter coating process. I also need to create a current of charge within the chamber. This current is necessary to allow the electrically conductive material to cover the specimens inside. I increase the voltage to about 45 milliamps. This current also is reacting with the argon gas that I mentioned earlier. Remember the cylinder of argon gas? Well, some of that gas has been pushed into this top chamber, and it's having an interesting reaction. Let's turn off the lights to get a better look. See that purple glow? It's the argon gas reacting with the electric current. Have you ever seen neon signs? Those signs use different gases to make the colors that you see. Different gases will make different colors. Neon gas glows orange or red, mercury glows blue, helium is gold, and argon is purple. So the next time you see a purple neon sign, you can impress your parents with your amazing science knowledge and tell them that there's argon gas inside. The sputter coating process only lasts for about 120 seconds, or 2 minutes, and then we're ready to take the specimens out. All I have to do is turn off the machine, open up the top chamber, and retrieve the specimens that I placed in here before. As you can see, the specimens look pretty different from what they looked like before they were sputter coated. As I mentioned, sputter coating just means to coat the specimens in an electrically conductive material. The sputter coater at the California Academy of Sciences uses a mixture of gold and palladium metals. I like to think of them as golden insects. Now this is the actual scanning electron microscope. It looks very different from the light microscopes that you are probably more familiar with. First of all, the microscope is connected to two computer monitors. The screen on the left is showing images that come from a camera that is inside the main chamber of the scanning electron microscope. So here's what is actually inside of the scanning electron microscope right now. Let's scan over to see where on the machine this is showing us. It's the inside of this box right here, which is where we'll be placing the stub with our specimens on it. Now I'm going to place the specimens inside this main chamber of the SEM. You may notice that I put on a glove on my right hand. I did that so I wouldn't contaminate the main chamber of the machine. The SEM is a very expensive piece of equipment, and I really don't want to break it. Once I open up the door to the main chamber, I carefully place a specimen inside on this main stage. Then I tighten the screw on the stage with a screwdriver to make sure that the specimen is secure. Then I carefully close the door to the main chamber. I also latch each side. In a moment, I'll be creating a vacuum inside the chamber so that air particles don't interact with the electrons inside. To create the vacuum, I simply press pump on the computer. This pumps the air out of the main chamber and creates a vacuum. It takes a minute for the vacuum to be created within the chamber, so I wait patiently for that to happen. Once the vacuum is created, then we can see our specimens on the computer screen. There are two specimens on the stub we placed inside. There's a Hemiptera, or true bug, and a Coleoptera, or a beetle. This is the true bug, and this is the beetle. One of the really neat things about the SEM is that it operates like a video game with a controller. This controller lets me move the specimens to the left, right, up, and down. I can even rotate them in a circle. I can visualize this on the computer screen. This allows me to focus on a specific part of the specimen that I want to take a picture of. During this SEM session, I was examining different types of insects and looking at the different mouth parts that they have. This is a true bug, and it has sucking mouth parts. You may have seen these when we were collecting grasshoppers out at SEM. They were the very small insects that were hopping in the fields. The true bugs at SEM were much too small to be able to see what their mouth parts actually looked like. So let's take a look at what their mouth parts look like using the scanning electron microscope. As you can see with the images on the computer screen, I can zoom further and further in for higher magnification to get a better look at these mouth parts. Now I have the exact image that I want, so I save that image as a file on the computer. I also take some images of the beetle mouth parts for the day. Once I'm done taking all the pictures that I want, I stop the vacuum on the machine and remove my specimens. To remove the specimens, I simply unlatch the main chamber and then gently open it. Then I use the screwdriver again to loosen the stub from the main stage of the scanning electron microscope. Once my specimens are removed from the main chamber, I gently close it again. And here's what the specimens look like after being in the SEM. They look exactly the same after they were sputter coated. This is great because I can use the same specimens later for more images. Because I may want to use these same specimens later, I need to keep them stored in a container so that they don't get damaged. This plastic container holds all of my SEM stubs that I use for my research. I'm adding this new stub, being careful not to destroy any of my other specimens. Then I close the lid, and I'm finished with the scanning electron microscope for today.